what is electrical field? Welcome back to physics electricity. Now here we look at electric field. Electric field means the region within which charges felt a force of electrical origin. Now, what do we mean? These two are charges, negative and positive charge. And like you know, these are going to what? Attract each other. Let's call this charge 1 and call this charge 2. In some textbook, you're going to see something going over here. Yes. We're going to see it in this form. Now, within this space is what we note as electrical field. This is a place where force are felt. Force of what? Electrical charge are felt along this region. For instance, if you bring a magnet, if you hold it together, if you face the negative and opposite side, they're going to be attracting each other. Now, within that space, that is where the electrical what? Field. That is where the force is felt. That is the electrical field. Now, the line of force is used to represent, that is the easier explanation, is to represent the what? Electrical field, or the line of what? Force. Now, we have to go into the formulas we're going to be looking at in electrical field. These formulas are going to help us with the aid of the theory derived by Coulomb. Coulomb is a man that derived the formula of what? Electrical force. Now, he stated that electrical force, the force of attraction between two charges, is inversely proportional to the what? Inversely proportional to the square of their what? Distance. So, distance square, which is F or 1 over R square. So, the force here is inversely proportional to the what? Square of their distance. So, from here now to this place is the distance of these two charges. Now, the force is inversely proportional in this form. He also observed that the force of attraction is also directly proportional to the product of the two charges. So that now you will say that F is directly proportional to the product of the two charges, which is what? Q1 and Q2 in an electric field. Now, because all of these are force, this is force, this is force, and this is force, we can join these together as a joint variation to state that Vf now is directly proportional to what? Q1 and Q2, the product of charges, and inversely proportional to what? R2. I know that we have to remove the sign of proportionality, and we have to remove that to put a constant equals to K Q1 Q2 over R2. Hope you know what this Q means. This is the charges we have over here. Now, as you can see, these charges are the same thing. This arrow means that they are repelling each other. So the charge cannot attract each other. I forgot to explain that. They're going to repel each other. In some textbook also, you found it in this form. Going in this form. So these are the same charge repelling each other, but online repulsing each other, but unlike charge are going to collect each other. So now, from this our stopping point here, what else do we need to know? So this is the formula you need to know about the what? Force of attraction on electric field. That is the first formula. Now, also, the constant of proportionality here, the value is equals to 8.9875 times 10 raised to power 9 Newton meter square per Coulomb square. This is the value of this constant that we have here. All right. Now, this constant, which is having this value, you're going to use it to calculate when you're given any of these to find a force. Also, this square, which is the constant of proportionality, is also equals to 1 all over 4 pi something like this. This is known as permittivity of free space. This sign here. This is E with a 0 below. All right, and then the pi is equals to 22 over 7. The pi you're going to use. So remember that this here is used here in finding the force. Now, when we use this formula, is maybe you are asked to find the constant of proportionality and you're given the permittivity of free space. All right. Now, mind you that the permittivity of free space also has its own value, just like the care here has its own value. Now, the permittivity of free space equals 8.954 times 10 raised to the power negative 12. Now, this time around, we're going to start from Coulomb. Coulomb square per Newton and per meter square. That is the value of the what? Permittivity of free space. You understand? So what are the formulas we have derived so far? The formulas we have derived so far is that the force F is equals to here product of the charge over R square. And then we also note that the constant is equals to 1 over 4 pi and free permittivity. All right, now with these two formulas, we are going to round up the electric field and look at questions to solve. Let's use this question as an example. It says, find the force of attraction between an electron and a proton of hydrogen atom separated by a distance 5.3 times 10 to the negative 11 meter if both of them possesses charge of magnitude of what you see. So now solution, we're looking for what? We're looking for the force, which is F. And we know that F is equal to what? Here, the product of the charge over what? Square root of the distance. And from the question, we note that the charges of, if both of them possesses a charge of magnitude, so the charges of Q1 and Q2 are the same value. All right. So we can say that Q1 is equals to Q2 is equals to what? 1.6 times 10 raised to the power 19, negative 19 Coulomb. Now that is it. Now the K, which is the constant, I gave you the value, did not give the value here. Now the constant is also used as 9 times 10 raised to the power 9. This value here, you can use it if you don't want to use the other value. So this one is more easier. So we're going to be using this particular one, value in solving with the constant of proportionality in Coulomb on electric field. So we're going to use this value for here. Now what about R? The R was given as separated by a distance of what? Of 5.3 times 10 raised to the power negative 11. Remember we're talking about charge of what? Electron and proton, negative and what? Positive. So the force now is going to be equals to, what is my K? My K is 9 times 10 raised to the power 9. And from this, I'm going to multiply it by the two charges multiplication. So the first one and the second one has the same value. So this is it, multiplied by the same value all over this other charge to square, which is what? The distance 5.3 times 10 raised to the power negative 11. Now we have to square it. And now the final answer after calculation will give you 8.2 times 10 raised to the power negative 8 Newton after the calculation. So that is it. Now there are more other difficult questions apart from this one. I'm going to be making the video of those questions one after the other so that by the end you're going to master it in every question. Now in our next video, we're going to look at another aspect of this particular electric field. Thank you. Don't forget the notification bell to be notified. And if you are not on my online class as a JAMB, NAPTEP, WAEC, GCE student, WhatsApp me on 081 539 57022 plus 23